Hello, I'm excited to join you at FoodTechIL today and to provide a satellite Earth observations perspective on providing agricultural monitoring in support of agricultural markets, sustainability, and food security decisions. My name is Inbal Becker Reshef, and I'm the director of NASA Harvest, which is NASA's food security and agriculture program. To provide some context for our work, as has become increasingly evident as we get further and further away from this sustainable development goal to a target of zero hunger, food security remains one of the most pressing issues we face in this century, especially in the face of increasing extreme weather events under a warming climate. And as such, innovation in developing robust and scalable measures to monitor the world's crops in a timely, transparent manner is a key component in helping to address this global challenge. With recent advances in Earth observing satellites, cloud computing, machine learning, and AI, we have the data and tools needed to monitor and track nearly every field across the world on a near daily basis. As COVID-19 continues to touch nearly every aspect of our daily lives, and recent droughts, floods, and conflict have devastated livelihoods and agricultural production, these have given an unexpected relevance and urgency to the need for improved agricultural information and have served to further highlight information gaps that satellite data can help fill. When people think of NASA or other space agencies, they often think of astronauts or space exploration and maybe even satellites, but they usually don't think about agriculture. In fact, the earliest Earth observing satellites were designed with agricultural monitoring as a key application area. And so in essence, what we have are satellites that are passing over us all the time, collecting information about the Earth's surface and the air above it in wavelengths of light beyond what the human eye can see. And these satellites then are providing us with data that are global, that are down at the field scale, and are timely, objective, and repeatable, as well as scalable with long, dense time records that enable monitoring our diverse landscapes and provide low-cost alternatives or enhancements to traditional agricultural monitoring. The importance of these data in informing life-saving decisions making cannot be overstated. And so this is, for example, I was showing an image of what the world looks like yesterday. And here is down, we have today data all the way down at the field scale on a near daily or even daily basis. And so in this context, NASA launched its food security and agriculture program called NASA Harvest in 2017, which sits within its applied sciences program. And under Harvest, our mission is to enable and advance the adoption of satellite data to benefit food security, agriculture, and human and environmental resilience, helping to bridge gaps between scientific findings and practical applications in order to expedite benefits. It's run out of University of Maryland. And in fact, this is an innovative program for NASA, not being run out of NASA headquarters directly. And that reason for that in part was to help this program be more agile and flexible, including in its partnerships, in particular with governments as well as with the private sector. And so it's implemented as a consortium of over 50 partners from across the agricultural sector. Harvest is a global program with over 35 active projects and organized across a variety of cross-cutting thematic areas and initiatives. In order to accomplish our mission, we have several different focus areas that are listed here. And these are underpinned by 3 remote sensing application areas, including understanding where and when crops are being grown, forecasting and estimating the productivity, and developing the evidence basis for adopting sustainable agricultural practices in the face of the changing climate. And so over the past few years, we've seen a tremendous increase in the interest of our activities across the agricultural sector, including from policymakers, humanitarian organizations, as well as ag tech startups and industry, as satellite data continue to generate new opportunities to provide accurate, reliable, and timely information for agricultural monitoring and provide crop-specific information from field to national to global levels across cropping systems. One of the priorities when NASA launched Harvest, as I said, was for us to actually be able to partner with the private sector, recognizing that public-private partnerships are going to be absolutely key innovation mechanisms that are going to be critical for reaching our goals. And so to enable nearly all of our activities, we have to have information on what crops are growing where and what their productivity is. And so when paired with ground data and machine learning models, satellite data can provide such information at global down to the field scale on where and when major commodity crops are growing and how those are changing through time in response to weather, market, and policies. Though one of the main challenges that still remains is access to ground data for training and validating remote sensing models, especially when we think about the more complex smallholder agricultural systems. And so to address these challenges, our machine learning team has been working extensively on innovating methods to learn from sparse heterogeneous labels for cropland and crop type mapping. And these provide field level information every season depicting which crops are growing where. And this is critical, for example, for informing crop area estimates, for agricultural insurance, as well as for feeding into yield forecasting and prediction models. And so we do have a lot of work also focused on yield estimation, as these are critical for supporting market transparency, for early warning of impending shortfalls, and for mobilizing humanitarian assistance, as well as for supporting, for example, efforts to evaluate and target productivity enhancing interventions, but also for informing farmer management decisions or, for example, services like insurance. And so while we have initially, we were working on yield forecasting models that were focused on the global scales or focused on primary crops and in the biggest production and exporting areas. More recently, we've started to adapt these models for the more vulnerable countries, the more smallholder and complex countries. And these are some of our early results in different parts of Africa. And we've also been working to adapting our models down at the subnational scale and even down all the way at the field scale. And this is an example of yield for spring rice in Vietnam with very good results and very low errors 2 to 3 months prior to harvest. And here we've evaluated the performance of that same model that I initially showed at the global scale and then at the subnational scale. And we are now working with 2 different companies in Latin America who've provided us with ground observations for soybeans and maize. And that's been very helpful for us to be able to adapt and enhance our yield forecasting models. And at the same time, that's enabled us to also support these companies in their services that they provide to farmers. And so when we combine such information like crop type maps with yield maps, as well as with management practice maps, these data can help to play a really critical role in building the evidence basis for climate resilient agriculture. And this is a major focus for a new initiative that we have called SARA, focused on sustainable and regenerative agriculture, which we're launching as a mechanism for bringing in both public and private sector together in a pre-competitive forum. Now, satellite data don't only provide us information for looking at current conditions or yield forecasts, but the long-term data record afforded by satellites such as Landsat also gives us a long-term global perspective on how our agricultural lands are changing. For example, tracking the rapid deforestation in South America for large-scale industrial ranching and soybean cultivation. And so this is an example from Matt Hansen's group on monitoring cropland expansion in South America over a 33-year period. And here we're going to zoom into 2 areas where you can see from 1985 to 2018, cropland area grew consistently across the continent at an average rate of 2 million hectares per year, resulting in an increase in area by a factor of 2.6, where the majority of new cropland was created through the conversion of pastures. Okay, so ultimately, our goal is to help transfer research into actionable, science-driven information in support of agricultural decisions and food security. And so I'd like to give a few different examples. And in the context of a globalized market, it's not only important for us to be able to monitor the large production and export countries, also critical for us to monitor those countries most at risk of food insecurity, where there's often less comprehensive and timely information. And so this is an example of the type of information we're providing at the global scale from the GeoGlam Crop Monitor initiative, which we coordinate. And this is a global assessment of crop conditions for the major commodity crops as well as food security crops, highlighting areas of concern and areas where crop conditions are poor, including at the moment, this is from our last assessment released a couple of weeks ago. And so this is really highlighting some of the areas of concern where conditions are poor, or in major production areas, like you can see over Canada, parts of the US, across in Russia and in Brazil. And this type of information is really critical, both for agricultural commodity markets and transparency, but also for early warning of crop shortfalls. And this kind of information is extensively used both by markets and trade, but by governments as well as by humanitarian organizations. And so here are some examples of different media that have covered these products. We provide them on a monthly basis, and have helped in the past to really inform decisions through early warning and helping to determine, for example, when, where, and how much and what kind of aid is needed. Through our Africa program, we have a large focus on capacity development. So we're not only interested on our end on developing models and methods, we're really interested in being able to develop and transfer that monitoring capacity and tools. And this is an example for the government of Uganda, demonstrating the impact that these kinds of data and tools can have when they're owned and operated by governments and enable the right information at the right time to inform government decisions that save lives. And this is an example from crop failure in the Karamoja region in northeastern Uganda. Another example of our work working with the private sector, here I'm showing two different examples where we were able to use our yield forecasting capabilities to help improve agricultural insurance by increasing the efficiency and cost effectiveness of the loss adjustment process. And here we're working in Ukraine with Swiss Re, as well as working with with farmer service providers in Latin America to provide yield forecasts and insights at the field scale that were integrated into apps and information products provided to farmers. Another example is from the derecho. This was a big windstorm that hit across the major soy and corn producing state of Iowa in the US in the summer of 2020. And here we were able to use free and open satellite imagery, in this case from ESA's Sentinel-1 data, to create a rapid assessment of the impact that windstorm had within 2 weeks after the storm, and looking at not only where did it damage crops, but also being able to estimate corn versus soy and how much was damaged. And some estimates were that the insurance industry took over 4 months to manually assess the damage that was caused by the storm, and a cost of $2.5 million. In another example is from our work with the USAID Famine Early Warning Network. Due to travel restrictions due to COVID, it could not conduct its usual crop assessment tour on the ground, and therefore experimented with what they called a virtual tour, which relied heavily in satellite data analysis. And in this case, a request was to look at if COVID-19 restrictions had and shortages that came on because of the COVID-19 restriction had an impact on crop planted areas in Eastern Africa. And another example in the context of COVID was a request we had by the government of Togo, which at the start of the pandemic instituted significant national restrictions, as many countries did, which impacted smallholder farmers. And to support these farmers, they launched a program called Yolim, which is a digital interest-free loan program aimed to improve yields and livelihood of farmers. And the problem was that they were using census occupation data to identify where farmers were that they were trying to reach under this program. And the census data underrepresented smallholder farmers, as many of them have different occupations as their primary occupation. And so they therefore requested that we develop a high-resolution crop distribution map within 10 days that they could use as a proxy to locate where smallholder farmers were across the country. And so we were able to develop this kind of a map within 10 days and provided it to the government of Togo in support of their aid program. And so really, given these recent events on the Earth observation side, there is an increasing recognition, so both in terms of, as we've seen the impact through COVID, as well as the increasing extreme weather events, there's a real critical need to better link and synthesize crop production prospects, as are afforded by remote sensing, to relevant economic, trade, policy data that are critical for better understanding and monitoring potential disruptions to supply chains across the complex food systems. And so we're therefore launching a new initiative focused on better integration of satellite observations into agricultural supply chains analysis, working with a number of UN organizations and international organizations. And so to conclude, advances in remote sensing and machine learning AI and cloud computing and digital data and GPS technologies have been revolutionizing the agricultural sector. And with the ongoing pandemic, with increasing extreme weather events under a warming climate, these are really continuing to highlight the need for more transparent, more timely, more actionable information from space that can help improve and inform food production decision, agricultural markets and trade, as well as disaster response measures and farmer decisions. And so cooperation between international organizations, between governments, but critically also with the private sector, are really critical for being able to help realize the full potential that Earth observations technologies can offer to help inform these key policies, decisions at the farm all the way through to the global scale. And with that, I'll thank you. We're always interested in hearing what others are doing and in partnering, and so please feel free to reach out and connect with us.
Hello, Sarai?
Yeah, I wanted to tell you that I had the best time at the FoodTechIL, and I was wondering if we can maybe book in advance next year's conference.
Understand, the series was really great, but absolutely not. Next year, here in Tel Aviv, face to face.
Yeah, can I have my agent call you? Okay.
Waiting to see you all in person next year in Tel Aviv.
Eitan, how was it working on this?
Well, actually, I think it was one of the interesting projects I've ever done. I work in 25 years in television. And it was a journey of knowledge, and it was great, really. No?
Yeah.
For sure.
Yeah.
So it's very tasty, it's very great.
Did you learn a lot of new things?
Yeah, it's a whole world I didn't know exist. It's actually things that going to happen in our life, in the world, and it's here.
It's mind-blowing.
Yeah, it's mind-blowing.
Amazing, right?
Absolutely.
Very healthy.
Yeah.
What, you shooting?
Yeah. I wanted to know.
She's the director.
So, let's
It's
go.
a wrap? It's a wrap?